Hello grade 10 students, welcome back. This is video lesson number 9 and I'm Madhu Badke. In previous video class, we started with polynomials. We learned the basic method of finding the zero of a polynomial and also interpreted the geometrical meaning of zero of a polynomial. In today's lesson, we will find the zeros of a quadratic polynomial and also establish a relationship between the zeros and the coefficients of a linear polynomial and also of a quadratic polynomial. All concepts and questions done in video class are to be written in your notebooks neatly like we do it in a classroom setup. In our previous video class, we have seen that the zero of a linear polynomial p of x equal to ax plus b is minus b upon a. Remember, to find the zero, we equate the polynomial to 0 because the 0 is that value of x which when substituted in the polynomial becomes 0. So when we equate this polynomial p of x equal to ax plus b equal to 0, we get this equation which on solving gives us its 0 minus b on a. Now what is term b? If you look at the polynomial, b is the constant term and a is the coefficient of x. So there is a clear relationship between the 0 and the coefficients of the polynomial. Let's find the relationship between the zeros and coefficients of a quadratic polynomial. The general form of a quadratic polynomial is ax square plus bx plus c, where a is not equal to 0. To understand, let's take an example. Let p of x be equal to a polynomial x square plus 3x minus 10. Now in grade 9 we have studied how to factorize this polynomial by sum and product method. The sum is the middle term, which is the coefficient of x term, and the product is multiplication of coefficient of x square and the constant term. So what we have to do is we have to factorize the product and get two numbers such that their sum is the middle term, x square plus 3x minus 10. In this, the product will be coefficient of x square is 1. So 1 into the constant term is minus 10. 1 into minus 10. So product is minus 10. Now we need to find two factors of minus 10 such that the two factors on adding give us the sum. What is the sum? The sum is the coefficient of x. So the sum is plus 3. So finding factors for minus 10, we get 2 and 5. Now we need to place the sign for 2 and 5 such that the product is minus 10 but their sum is plus 3. So the plus will go with the bigger number and minus will go with 2. So minus 2 plus 5 on adding gives us plus 3. and on multiplying it is minus 10. Now to factorize, we need to split the middle term as sum of these two factors. So x square plus 5x minus 2x minus 10. This is our middle term, which we have split into two numbers. Now taking the first two terms, we find common, so we get x plus 5 in bracket. Now from the remaining two terms also we need to find out a common factor such that the numbers in the second bracket are exactly the same as the first bracket. So if we take minus 2 out, then we get x plus 5 in the bracket. Now taking x plus 5 common, we are left with x minus 2. So these are the factors of polynomial x square plus 3x minus 10. Now to find the 0 of this polynomial, we equate the polynomial to 0, which implies x square plus 3x minus 10 is equated to 0. But we have factorized this polynomial, so we'll use the factors x plus 5 into x minus 2 is equal to 0. Now product of two numbers is 0 if either of them is 0. So this implies x plus 5 is 0 or x minus 2 is 0. On solving each equation, we get x equal to minus 5 and x equal to 2. So the zeros of this polynomial are minus 5 and 2. So now we have the zeros of this polynomial. Since it is quadratic, there are two zeros. Let's find the sum of zeros. The sum of zeros is minus 5 plus 2, which is equal to minus 3. Now find this number in the polynomial. It's the coefficient of x. Minus 3 can be written as minus 3 on 1. In the numerator, we have minus of coefficient of x divided by, in the denominator, we have 1, which is the coefficient of x square. So the sum of zeros is related to the coefficient of x and x square. Similarly, let's find the product of the zeros. Which is minus 5 into 2. The product gives us minus 10. Minus 10 can be written as minus 10 upon 1. Now find this number in the polynomial. Minus 10 is the constant term. So we can write this as c upon 1 is the coefficient of x square. So minus 10 is the constant divided by coefficient of x square. So we can see that the product of zeros is also related to the coefficient and constant of the polynomial. These results are true for any quadratic polynomial. So we can generalize this result if alpha and beta are the zeros of a polynomial in x, which is quadratic, that is ax square plus bx plus c, then the sum of the roots will be alpha plus beta. We have found that the sum of the roots is minus coefficient of x divided by coefficient of x square. So coefficient of x is b, so minus b divided by coefficient of x square, that is a. So we get this generalized result. Similarly, the product of roots will be alpha into beta equal to the constant term divided by the coefficient of x square. So the constant term is c divided by coefficient of x square is a. This gives us the second relation between the coefficients of quadratic polynomial with the roots. Now let's verify this result by finding roots of some more quadratic polynomials. Find the zeros of following polynomials and verify the relationship between the zeros and the coefficients in each case. We will first find the zeros of this polynomial by factorizing by sum and product method. So we will split the middle term. Let's write down what is the product. The product is obtained by multiplying the coefficient of x square and the constant. So 4 into minus 3 is minus 12. So the product is minus 12. Now we have to find the factors of minus 12 such that the sum of these factors is equal to the sum. What is our sum? The sum is minus 4. Sum is the coefficient of x. So 4 and 3 are also factors of 12, but if you add or subtract them, you don't get minus 4. So let's try 6 and 2. 6 to the 12. On subtracting 6 and 2, you get 4. But you want minus 4. So the minus should be with the bigger number and plus with the smaller number. So now the product of minus 6 and plus 2 is minus 12, and the sum of minus 6 and plus 2 is minus 4. So splitting the middle term, we get 4x square minus 6x plus 2x minus 3. Now find common from the first two terms and the last two terms. So from the first two terms, 2x is common. 2x minus 3 is left in the bracket, plus, now the second bracket also should contain the same numbers as the first bracket, so 2x minus 3. What common will you take so that you get 2x minus 3 from the remaining two numbers? 1. Now this can be written as 2x minus 3 into 2x plus 1. In order to find the 0, p of x should be equal to 0. So let p of x equal to 0. If p of x is 0, then the factors of that polynomial are also 0. This implies either 2x minus 3 is 0 or 2x plus 1 is 0. Solving each equation, we get x equal to 3 upon 2 and x equal to minus 1 upon 2. So alpha is 3 on 2 and beta is minus 1 on 2. Now according to the question, we need to verify the relationship between the coefficients and the roots. So let us write down the polynomial p of x equal to 4x square minus 4x minus 3. In this polynomial, a is 4, B is minus 4 and C is minus 3. Now we will find out alpha plus beta. Alpha plus beta is 3 on 2 plus minus 1 on 2, which is equal to 3 minus 1 on 2, which is equal to 1. Now we will find out minus b upon a. So this minus is with the expression. We'll keep it as it is. Substitute the value of b, that is minus 4, divided by a, which is 4. So on simplifying, this becomes 1. Minus minus becomes plus, and 4 cancels. So we can see that from these two, alpha plus beta is equal to minus b upon a. This relationship is verified. Now we will verify the product of the roots. So for that, let's find out alpha into beta. Alpha is 3 on 2, beta is minus 1 on 2. Let's multiply, we get minus 3 on 4. Now we will find c upon a. The constant term of the polynomial is minus 3 and a is 4. So both results are equal. This implies alpha plus beta is equal to c upon a. So we have verified the relationship of sum of roots and the product of roots with the coefficients of the polynomial. Second question, p of x is equal to x square minus 5. Now here we cannot use the sum and product method because the middle term is not there. So to factorize this, let's first equate the polynomial to 0. So x square minus 5 is equal to 0. Now the left hand side can be written as x square minus root 5 square equal to 0. Now this is a plus b into a minus b. So writing the factors, x plus root 5 into x minus root 5 is equal to 0. Equating each bracket to 0. We get the roots x equal to minus root 5 and x equal to root 5. So alpha is minus root 5, beta is root 5. Writing the values of a, b and c from the polynomial. A is the coefficient of x square, that is 1. B is the coefficient of x, but there is no x term, so b is 0. And c will be minus 5. Now we'll find out alpha plus beta, that is equal to minus root 5 plus root 5, which is equal to 0. Find minus b upon a, 0 upon 1, which is also 0. So this implies alpha plus beta is equal to minus b upon a. Likewise, find out alpha into beta. Minus root 5 into root 5, that will be equal to minus 5. Then find c upon a. C is minus 5 and a is 1, which is minus 5. We see that both these results are equal, so alpha plus beta is equal to c upon a, and we have verified the relationship. Try this problem now. For what value of k minus 4 is a 0 of polynomial x square minus x minus 2k plus 2 in brackets. For minus 4 to be 0 of this polynomial, p of minus 4 should be 0. So we will substitute minus 4 in this polynomial and equate it to 0. So minus 4 square minus minus 4 minus 2k plus 2 should be equal to 0. So 16 minus minus becomes plus, 16 plus 4 minus 2k, open the brackets and change the sign. This is minus 2k equal to 18, which goes to the other side and becomes minus 18. So k is equal to 9. To solve this question, we use the fact that if this number minus 4 is a 0, then value of polynomial at minus 4 should be 0. So we substitute in the polynomial minus 4 in place of x and equate it to 0 and then solve. With this, we come to the end of this video lesson. Your assignment is exercise 2.2, question number 1. Goodbye.